Hi everyone, welcome back to Life Technologies YouTube channel and thank you for watching. So today we are continuing with our Huawei Lab simulation series where I've been demonstrating how to implement different networking principles or networking protocols on Huawei routing and switching devices. Please watch our other episodes for a better understanding of how to implement different networking technologies on Huawei routing and switching devices. So in today's episode, we'll be focusing on how to implement BGP, MPLS, IPVPN, hub and spoke architecture. So the hub and spoke architecture is a network design where we have a central site, the hub. So the central site, we call it the hub, and then we have multiple remote sites, which we call the spokes. As you can see in this topology, we have the HQ. So HQ in this case will be our hub. And apart from the HQ, we have different branches. We have branch 1, branch 2, branch 3. And we need to ensure that there is communication between the branches and the HQ. And also between the branches, we need to ensure that there is communication, for example, from branch 1 to branch 2. So this is a very common networking architecture that is mainly implemented for enterprise networks. And for the communication between branches, we have two options. The first option is direct communication between branches, where the traffic doesn't have to go to the central site. But then that one needs to factor in the security aspect of the network. So you can directly communicate from branch 1 to branch 2, branch 2 to branch 3 without going to the HQ. The second option is communication via the HQ. So all the traffic from branches has to go to the hub, which is the HQ, and then it has to come back to the branch. So if branch 1 has to communicate with branch 3, all the traffic has to be forwarded to the hub, then back to the branch 3 via the MPLS backbone. So these are the two options, and in this lab we'll be demonstrating a scenario where we have branch-to-branch communication via the hub. So the traffic has to be sent to the hub, the HQ, and then come back to the branch. So for our lab setup, this is our topology. As you can see, we have the MPLS backbone, which is in AS65100. In this AS65100, our MPLS backbone will be running ISIS to ensure that we have reachability between the PEs. So we have PE2, PE2, and PE4. And then we have branch 1. Branch 1 has PEC, which we are calling CE or PE01. In this branch, we'll be running OSPF as our PEC protocol. So we'll be configuring OSPF between PE2 and PE1. And then we have PC3. So PC3 will be simulating a customer who is in branch 1. Then we have branch 2. Branch 2, we have a 65003. So we'll be running BGP between the PE and the CE. And then we have PC2 that will be simulating a customer in branch 2. Then the hub is in a 65003. Which is P1. So P1 is our hub site and it's connecting to a PC1. So PC1 is also used to simulate a customer who is, or a client who is connected at HQ and has to communicate to the branches. So we have two branches, branch 1 and branch 2. Then we have the hub, the HQ, which is in AS65003. You can see that we are using the same AS number between branch 2 and HQ. So we need to implement some workarounds to ensure that the route exchange is working okay. Remember, BGP has some route control techniques, the loop control techniques. So we need to ensure that we are able to exchange routes between a 65003 of HQ and a 65003 of branch 2. So this is the setup. And we need to ensure that when we do a trace from PC3, the traffic has to go all the way to HQ and then back to P2 and then to PC2. So this is the setup that we'll be using to demonstrate the hub and spoke architecture in this lab. So for the configuration steps, we need to follow some steps. As I've mentioned, we are having OSPF, we are having SIS, we are having eBGP, we are having our MPLS backbone. So we need to ensure that we have configured all the required basic configurations before we start checking our connectivity and we start testing our communication between the clients in different branches and also the client in the HQ. So our configuration step 1 will be to just basic configuration of device IP addresses, ISIS, that we'll be using for connectivity for the backbone network. So these are the configuration that we are using. We need to set the system name. That is a best practice that you always have to do. And then we are configuring MPLS. So remember, it's BGP, MPLS, IP, VPN. So we need to enable MPLS on all the devices in our MPLS backbone, and also enable MPLS LDP for label distribution. So I've mentioned in the MPLS backbone we are using ISIS. So we need to configure ISIS on the devices in our MPLS backbone. So we configure ISIS process 1. We give it IS name of PE2 and then the network entity as shown. And then for other interface configuration, we just need to configure IP address, enable ISIS, and then we enable MPLS and MPLS LDP on the interfaces in the MPLS backbone. And then we have loopback 0 interface. So these are the configuration that we are doing on devices in our MPLS backbone. And the second step of our implementation is to create VPNs on PEs. Remember, this is MPLS, BGP, MPLS, IP VPN. So we are using VPN to control the communication between these different sites. So the second step is to create VPNs on PEs, and then we have to bind VPNs to the relevant interfaces and assign IP address facing to the PEs. So starting with PE2, we are creating a VPN instance, VPN A, and then we are assigning the route distinguishers and the route targets. Remember, the route distinguishers are to make the routes unique, allowing customers to use overlapping address space. And then we have the VPN targets, or the route target, that are used to control route export and import. So we need to do proper planning of this. So once we've created the VPN instance, the second step is to configure the interface facing the CE, where we are binding the VPN instances. And once you bind the VPN instances, that's when you apply the IP address, just to avoid doing it again. If you are to configure the IP address and then bind the VPN instance, the IP address will be removed and you have to reconfigure it. So it's always better to bind the VPN instance and then configure IP address. So on P2, we are creating two VPN instances, VPN in and VPN out. And this is because we need to have a VPN instance that is controlling route exchange coming from the CE and route exchange routes that are being advertised to the other PE. So on P2, we are creating two VPN instances, VPN in, that will be receiving routes, and then VPN out, that will be sending routes. So this is just used to implement the spokes communication via the HQ. Remember, we are getting routes from the spoke, and we also need to advertise routes to the spoke. So we have VPN in that will be receiving routes, and then VPN out that will be used to send routes on the P router. Remember, P router is our spoke. If I just show you the topology again, the P router is our spoke in this set, in this lab setup. So we create two VPN instances. We are giving them different route distinguishers, and then we are also configuring the route targets. So once we've done the same, we configure the interfaces. We have one interface that we are binding VPN out, and then we have a sub interface that we are binding the VPN in, and then we assign IP address as per the planning. And then on PE4, we only create VPN A, and then we are also binding the interface facing the customer. Remember, as usual, you have to configure the route distinguisher and the route targets. So this is the second step. On our third step, we need to configure eBGP between backbone routers. So remember, we are using the VPNs, the MPLS VPN. So we need to configure VPN before peering between these routers so that we can be able to exchange the VPN routes between different PEs. So on PE2, we are configuring BGP. We need to define the router ID as the loopback 0 IP, and then we also configure the connect interface to be loopback 0. So these are just basic configuration for BGP. And then another thing that I need to mention is that P2 is configured as our RR. So remember, that is eBGP. So you need to have a route reflector to ensure that routes are exchanged from P2 to P2 and then P4. If you don't have route reflector, we will have a point of disconnect where if P2 advertises routes to P2, P2 will not advertise the routes to P4. Remember, we have the concept of split horizon for eBGP. So we configure P2 as our route reflector to reflect routes to the other routers P2 and P4. And then on PE4, we are just configuring the BGP peering relationship to P2. The next step 4, will be to configure OSPF. Remember, in this setup, we are using OSPF in branch 1. So we need to configure OSPF between P1 and P2. And on P2, remember, we have a VPN instance. So we need to configure OSPF with that VRF. So in this step, we are configuring OSPF between P2 and branch 1, P1, and then IP addresses on interfaces to the PC. So we have the PC, which is, if I go back to, we have PC3. So PC3 simulates a client in this branch. So we need to advertise this network to OSPF. So we are configuring OSPF, and we are enabling it on the interfaces, loopback interfaces, and also the interface that is facing the customer. So once we've done this, we need to verify that our OSPF is up. On P2, you remember I mentioned we are using VPN, so that's why we are creating OSPF with that VPN instance, VPN A. And then we are importing routes from BGP. And another thing that in BGP, we are importing OSPF using a route policy, and we are only importing this IP that is coming from the customer. So that is 172.0.0/24. So we configure prefix to match this IP prefix, and then in the route policy, we are using this IP prefix. And then in BGP, we are using the route policy so that it's not just importing all the OSPF route. We are only importing this specific route from OSPF to BGP. So we can verify that our OSPF is up on this P2. Display OSPF peer. You see that we have OSPF peering session between P2 and P1. I can display OSPF route. We have these routes coming in from OSPF. If I display BGP routing table, display BGP VPN v4, all routing table, you can see that these routes is coming in under the VRFs. So our OSPF is up. We have imported the necessary routes to BGP, and we have also imported BGP to OSPF that to ensure that we have end-to-end connectivity. So once we have done that, the fifth step is to configure eBGP between HQ router and P2 and create. So in this new, we are also creating an interface, interface Ethernet 000, and it's pointing to the customer, and we are assigning IP address 172.100.100.254. On the PC will be assigning 172.100.100.1, and we are configuring BGP towards the CE. So these are the configuration on P1, and then P2. On P2, remember we are so on P2 we are also configuring peerings towards the CE, and in this case we need to ensure that we are implementing some techniques. For example, you can see that on VPN in we are using the command substitute AS. So remember the CE and the PE are in the same AS. I mean, like in this setup, the hub and branch 1, they are in the same AS. So if the routes from the branch are advertised to the hub the way they are, they will be dropped, because remember the BGP uses AS path to control loops. So it will be dropping the routes because it's seeing its own AS in the AS path list. So you need to substitute the AS on P4, so that P4 will substitute AS 65003 with the local AS and advertise the routes to AS 65003, which is the hub. Another command that we are running is allow AS loop, and then we are making it to. So when the routes are being exchanged, if a router finds its own AS in the AS path list, it detects this as a loop and will drop the route. But then we are making, like, we are configuring that peer to allow at least we can have 2 repeating AS numbers in the AS path list, and it will still accept the route. Remember, we need to ensure that we have communication via the hub. So these are 2 important commands that you need to include when you are configuring the P2 with VPN in and VPN out. So our last step of configuration is to configure eBGP between branch 2 and P3 and advertise the subnet connecting the PC. So we are configuring P3, we are configuring BGP peering toward the CE, and remember here also we are doing the same. We are substituting the AS. So we run the command substitute AS. So once we've done our configuration, we can verify that our protocols are running okay. On this P2, we can display BGP, VPN v4, all routing table. Remember, this is our route reflector, display BGP, VPN v4, all peer. So we have peering sessions to these PEs, and we also have the one for VPN in and VPN out towards P1. So on P4, display BGP, VPN v4, all peer. You can see that we have 1 peerings to the route reflector and then 1 peering to the CE. So we expect that the route exchange is okay. So on P1, given that we have advertised the IPs from the PCs, we expect that from P1 we should be having, if I display IP routing table, you can see that we have learned these 3 blocks from the other CEs, and we can be able to ping them from PC. So we can try to ping. From here I can ping 172.100.100.1. Remember, this is PC1, and then we can also ping 172.200.200.1, which is in branch 2. We can do a trace from PC1. If we do a trace from PC1, remember it will have a direct communication with the branches. So we can trace to, and you can see the traffic flow. We can also trace to 0.0. So it's coming all the way from P1 to P2 to P3 and P1 and then to PC3. Same way it will flow to PC2. From PC2 we can trace to the branch 1 and branch 2. We test the communication again. So we have 172.0.0.1. Let me see again, 172.0.0.1. I don't know if this one is configured. I will trace from PC3. I'll trace 172.200.200.1. So from this trace, you can see that our traffic flow is coming all the way from PC1 to P1 to P2. At P2, it has to go to the hub and then come back to P2 and to P4 and then to PC2. So it's flowing from, let me just take a snippet. So our traffic flow is coming from PC3 to P2. We have a VPN here for in and out. So it goes to the hub, then from the hub it goes to PC2. And this is what we were targeting to simulate in this lab. So this is how simple it is to simulate hub and spoke architecture on Huawei routing devices. These are the configuration steps. You need to configure IP addresses on the interface, enable MPLS in the MPLS backbone, and configure routing protocol that has to ensure that we have reachability between these nodes. And then you need to configure VPN instances, assign route targets and route distinguishers to control the route import and export, and also to make the routes unique. And then you need to configure BGP peering sessions. You need to have a route reflector just to ensure that it's in charge of reflecting routes between different nodes. The fourth step is to configure the peering between different branches and the P's. And then the final step, what we did was to now configure branch 2, the peering which we are using BGP protocol. And remember, I've mentioned two things, the substitute AS and the allow AS loop. So these are important commands that you need to add for you to be able to achieve connectivity between these two nodes. Another option would be to use a different AS between the branch and the hub. Then you don't need to implement all these allow AS loop and substitute AS. So this is the end of our lab. Feel free, if you have any questions, you can leave them in our comment section. And please feel free to reach out if you need any clarification. And also kindly subscribe to our channel for more upcoming videos. Thank you.